This is an interval of the Doe Creek Formation, or Doe Creek member of the Cascapoo Formation, which is centimating in age and is the first clastic wedge that's in the finer grained Cascapoo, and it's just above the Dunvegan Formation, and it's mostly studied in the northwest part of Alberta, and it's really well known for its characteristically amazing bioturbation. And this core was logged by Scott Reed. He did his MSc with George Pemberton in the early 2000s, did superb work on the Doe Creek, and definitely studied core that is fascinating from an ichnological point of view. I'm not going to provide a strip log of this core in this presentation here because it's mostly just upper offshore, offshore to upper offshore, and really this really is chosen for its exemplary display of several ichnogenera. If you look up through the core, from the bottom here, it goes from box 8 all the way up to box 1 or 2. I guess must be box 1. I can't remember. And you can see the uppermost part of the core is so dirty. I didn't even really bother washing it because it just wasn't really worth looking at in comparison to everything else. So very quickly, looking lower down in the core, what are some of the features that we have labeled for you and that you can observe for yourself, especially with the help of the labels? You can see down here, look at these little sprida, we call them. These are truncated burrow walls that are made as the burrow shifts laterally or vertically through the sediment. This is Zoophycus, and a really nice example. So you can watch for some of those. There's several labeled in this core. There's lots of little examples with smaller amounts of sprida in them, and like this one here, which might be a tychicnus. The Zoophycus generally has to go right across the core. There's another trace fossil called Rhizocorellium that can look like Zoophycus as well, but for the most part, these are Zoophycus in here, although there are Rhizocorellium in this core, and we'll try label some for you. These vertical irregular traces are U-shaped burrows that have shifted upwards or downwards, and those are called Diplocraterion. And speaking of Rhizocorellium, these paired traces here are probably related to a very small Rhizocorellium caught in end view in the core. And if you look at the posters on the side, it'll show you the overall morphology of Rhizocorellium, kind of a sideways horseshoe that connects to the sediment-water interface. Other examples of tychicnus. Now, as you go up through the core, you'll see a variety of things. More vertical Diplocraterion, some larger burrows that we might call thalassinoides. And if we keep looking through this, I'm hoping we'll see a nice example of Asterosoma. If not, I've got some close-ups of Asterosoma that we'll be able to look at. There's a beautiful, big, long Diplocraterion. That's at 942. And then some smaller vertical burrows that are just simply scalethos. Here's another Diplocraterion, so you're probably getting an eye for those. And then these little black hooks are these horizontal meandering trace fossils, for example, like Helminthopsis, that are being caught in cross-section. And also these little specks here are these little branching trace fossils called chondrites. And so there's a lot of trace fossils in here, aren't there? It's a diverse assemblage. And in a healthy proximal offshore or upper offshore environment, this is more or less what we expect with mixed substrates. We get a good diversity, good sizes. You can see here's some larger trace fossils as we go up even further. Not entirely sure what these are. They're open and they're sand-filled, might be in part thalassinoides, but they've got a very irregular form otherwise. I'm just going a little further up so we can get into the zone of more Zoophycus up here. Those will be labeled. And these are the Asterosoma here, okay? And those Asterosoma are basically probes radiating out from a central area. The Asterosoma is star-shaped, stellate, and these probes have a sandy core and a reworked outside, and so you'll tend to see 2 or 3 or 4 of them together. and we'll get a close-up of Asterosoma too. We also have these larger diameter burrows that are sand-filled, and you can see it's even laminated sand-filled, so it probably filled during a storm, but that's Thalassinoides, generally a shrimp burrow. And we can go to the next core quickly. And you'll see that as we go upwards, it gets a little bit sandier, but then it gets shalier again. Let's have a quick look in there. And in here we'll see some examples that look like Asterosoma. Chondrites, Thalassinoides, and more Zoophycus, but a different expression of the Zoophycus, where the sprite are hard to see and they're just appearing as kind of slaty or clayey looking slashes. And even further up, you start to see a bit more of the little black hooks and whatnot of Helminthopsis and Phycosiphon. So a really good offshore example of offshore bioturbation. And if we look at some of the close-ups, we can actually see some of the characteristics of some of the trace fossils. This is one of the Asterosomas that you'll see further up, and the Asterosoma has this sandy burrow fill, and then it's concentrically lined around it, and it generally occurs in sets of 2 or 3. Here's another one here, and I'm not entirely sure, but this might be the edge of one over here. I just won't highlight it because I'm not definite. And then in this image also are some of these larger sand-filled blobs that we would refer to Thalassinoides. And look at, now we can see those black hooks of Helminthopsis or Phycosiphon. They can be very similar, and they mean very similar things in our interpretations anyway. So in core, as long as you recognize they're kind of that Helminthopsis, Phycosiphon class of things, it's probably a good start anyway. These look like Helminthopsis to me because they form such discrete, thick, fecal-filled meanders. And this here is a little lined burrow that we used to call Terebellina, but that name got confused with Foraminifera, and so now it's just called Schaub cylindricnus, but a really common offshore marine trace fossil. Here's a close-up looking at some of the Thalassinoides in the core, looking at some Tychicnus perhaps in the core, but I really wanted to get this close-up of this Diplocraterion where you can see the form, and these are the sprita that actually define the Diplocraterion form as it moved upwards through the sediment. And look for this part where we've labeled it for better. I'll zoom these in a little bit. Asterosoma, where we have the causative burrow and then the reworking concentrically around the burrow, and another example here occurring in our clusters of 2 and 3, and a different view perhaps of Asterosoma, caught obliquely a little above. And then finally a close-up of our Zoophycus as it occurs in core, where now you can really see the sprita that are developed as the causative burrow shifts through the sediment, and so that the burrow was actually migrating in this direction, and these are kind of the truncated burrow walls left behind it. Zoophycus can be quite large. In the scale of core, it's hard to appreciate, but the Zoophycus itself, there's some examples in the rock record that are approaching 1 meter in diameter as these big whorls of burrows that just keep shifting in this helical fashion over time, making these large networks, if you want to call them large pathways of burrows that form these large helicoils. And over time, the animal must spend many years making just a single zoophycus as it deposits feeds.